All right, first question here. Write an equation, all right? So we got our dots in there and connected them. It says write an equation that reflects this relationship and use the equation to finish the table on the next page. So I need the slope. So again, I can do 150 over 100. Reduce that. I could have chosen this one. 300 over 200. Either way, it's going to reduce to 3 over 2 or 1.5. So that is my equation. 1.5x or 3 over 2x. Now to get that into a table, from going from left to right, I will take it times 1.5 or 3 over 2. This way I would have to divide by 1.5. So 1,000 times 1.5. 1,500. 2,001 divided by 1.5. 1,334. And 1 times 1.5 is, of course, 1.5. Now, do you remember from yesterday, this has got a special name. Remember what that's called, the number next to the 1?
The multiple.
Proportional relationships.
It's called the constant of proportionality. Constant of proportionality, or the slope, right, if you're looking at an equation, but the number next to the 1 has that special name. Question number 2. Students are selling raffle tickets, $24 for every 10 raffle tickets they sell. Write an equation, okay, write an equation. Amount of money equals 2.4 per R per ticket, per raffle ticket, right? How'd you get 20 or 2.4? $24 divided by 10 to figure out how much each raffle ticket is. So again, that number is the constant of proportionality. That number is the slope. That number will help us going forward. Next one, label and scale the axes and graph M on the vertical axis. That would be money, right? And then the bottom would be R, raffle tickets. So what do you want to go by?
Twos.
Twos.
Yes.
Both ways?
Yes.
I went by 10.
I did 2. But
10's going up?
twos.
Oh, no, I went by
10's going up, 2's
24
on
is
bottom.
going up.
You went by 24 is going up.
Yeah,
And the bottom you did 10?
yeah.
Fine.
I'm so mad at you. You switched my twos to
This
tens.
makes it easier.
And you went by 24s?
Yeah.
That's convenient. Nothing wrong with it though.
I don't even know how to count between.
How hig'd you go?
182,
Okay, give me after 96 to make it quick then.
110, 134, 158, 182.
All right, so 0, 0, please put that one on there always, right? 0 raffle tickets would be $0. The other one they gave us was 10 and 24.
You can just,
So 20 and 48, 30 and 72, right? Connect the dots. Now everybody's graph might look a little different, but it should be a line that goes through the origin, regardless of what you have.
I went by 20s and 10s.
Perfect. Still should be a nice line, linear relationship. How can you tell whether a line slope is greater than 1, equal to 1, or less than 1? Well, greater than 1 is going to be
steeper.
steeper.
Stepper.
Okay. This one is what we would call, I guess, a normal slope of 1. The baseline, however you want to say that. I can't even see what I'm writing. Less than 1 would be less steep. Another way to phrase less steep, or are we good with that? All right, we're good with that. Less steep, flatter,
Not as.
Shorter.
Yeah.
shorter. I don't know about shorter. Like the line length is the
More
same.
weirder.
All right, question number 4. I gave you a hint on this one yesterday. So I said plug in some points for x and y. That would give you 3 over 11. All right, so I did that. I plugged in 3 on top. Obviously, that would be 3. And then I plugged in 13 because 13 minus 2 is 11. So that is going to be a point on my graph, 3, 13. And then I did it with 2 negatives, right? I wanted negative 11, or 3 over negative 11, because that would make a positive again. So I plugged in negative 3, and then I needed to get negative 11 on the bottom, so I did negative 9 minus 2, that would be negative 11. So there is another point, negative 9, negative 3. So I plugged in these 2 points on a graph, and I connected the dots. So there's what that would look like. Again, I just plugged in 2 points and I connected the dot. Questions on any of them?
9.
All right, then go ahead and do today's warm-up and then we'll get rolling with lesson 4.